Thank you very much. Firstly, I would like to thank the organization for the invitation to participate in this meeting. My name is Marta Mesias, and I work at the Institute of Food Science, Technology and Nutrition in Madrid, Spain. My presentation will be focused on a less healthy aspect of coffee consumption related to the exposure to chemical process contaminants, and specifically to acrylamide. It's well known that during the roasting of coffee, a different chemical reaction happens, and among them, the Maillard reaction is highlighted. This reaction takes place during the thermal treatment of foods, and through the interaction between amino groups from amino acids and carbonyl groups, mainly from reducing sugars. This reaction is responsible for the formation of aroma, color, and flavor, which are sensorial aspects especially appreciated in the case of coffee. However, despite this positive effect, this reaction is also related to negative effect, since its development, different compounds classified as chemical process contaminant are generated, and one of these compounds is acrylamide. Acrylamide is specifically generated when the amino acid that reacts with the reducing sugars is the free amino acid, it is the asparagine, the free amino acid asparagine, at temperatures higher than 120 degrees in low moisture condition. The problem linked with exposure to this compound is the toxicity, since it has been classified as probably carcinogenic for humans. In 2050, EFSA, the European Food Safety Authority, affirmed that acrylamide in food potentially increases the risk of developing certain types of cancer in knowledge group, and therefore acrylamide involves a risk for the consumers. Following this opinion, in 2017, the European Commission published the first regulation focused on acrylamide in foods, establishing mitigation measures and benchmark levels for the reduction and the control of these compounds, or the presence of this compound in the main source of the exposure to acrylamide in the diet, that are coffee, cereal-based products, and potatoes-based products. Benchmark levels are considered as reference values for the industry, so the companies should try to ensure that the food contains acrylamide concentration below these reference values. In the case of coffee, benchmark level has been established as 400 micrograms per kilogram for roast coffee, 850 for instant coffee, and values between 500 to 4,000 micrograms per kilogram for coffee substitute made from cereals, chicory, and a mixture of them. The highest values for instant coffee are due to the additional formation due to the temperature applied to the extraction process, and also because of the concentration of the compound in the soluble fraction. Why acrylamide is generated in the roasted coffee? Because the coffee bean contains an important amount of precursors of acrylamide, both asparagine and reducing sugar, and because this food is suggested to high temperature during the roasting process, temperatures higher than 200 degrees, and resulting then in a fast loss of moisture. This characteristic makes the condition favorable to the acrylamide formation. Regarding the precursors, in the case of coffee, the limiting factor is the content of asparagine, and it's possible to find the correlation between the asparagine content in the green bean and the acrylamide that is going to be formed during the roasting process. And considering the levels of the precursor, it can be demonstrated that the coffee species, the coffee variety, can affect the acrylamide formation, since Robusta contains higher amount of asparagine and higher amount of reducing sugar, promoting then a higher amount of acrylamide formation as compared with Arabica. Through the global roasting process, from the bean to the beverages, from the total coffee preparation chain, different factors can affect the acrylamide formation, and they can be controlled in order to reduce the formation of this contaminant, and we are going to comment some of these factors. Regarding the coffee bean, as mentioned before, the acrylamide formation depends on the precursors of the acrylamide in the coffee bean. And it is not only affected by the coffee variety, but also by other agronomic, geographic, and climatological factors, including the type of soil, the use of fertilizer, or the extent of maturity of the harvested fruit. The pre-roasting treatment can also affect the chemical composition of the bean, and at this point, one mitigation strategy is the application of the enzyme asparaginase that converts the asparagine in aspartic acid, decreasing then the levels of the precursor. However, this treatment is not very effective in the case of coffee. On the one hand, because of the hardness of the coffee bean that avoid the penetration of the enzyme, and it cannot take action. And on the other hand, because together with the formation of aspartic acid, it is released ammonium, and it can be affected from a sensorial point of view, conducive to undesirable organoleptic characteristic. The roasting process also affects the acrylamide formation, and at this point it's important to mention that acrylamide is not the final product of the Maillard reaction. It's an intermediate compound, and it is affected by the degree of the thermal treatment. It reaches a maximum level and then decreases, meaning that the elimination predominates over the formation. And this characteristic happens in the case of coffee. During the roasting time, the acrylamide formation exponentially increases, reach a maximum level, and then decrease, meaning that the degradation predominates over the formation. And this decrease happens because of the volatilization of the compound, and also because of the interaction between acrylamide and other components in the food matrix, for example, melanoidins. This behavior can explain why the highest levels of acrylamide are found in the lighter coffee, and when the browning progresses, the levels of the contaminant decreases. Despite, unlike cereals and potatoes, in the case of coffee, higher color doesn't involve higher formation of the contaminant, higher concentrations. And another mitigation strategies can be applied in the roasted coffee. For example, try to eliminate the acrylamide already formed through the application of different treatments, and also trying to prolong or extend the storage, promoting then the interaction between acrylamide and other components in the coffee matrix, for example, with melanoidins. From these mitigation strategies, those included in the European regulation are focused on the recipe and on the processing. On the recipe, taking into account that Robusta beans tend to have higher acrylamide levels than products based on Arabica beans, and on the processing, trying to apply the application of asparaginase, or try to reach the best condition for roasting in order to not to promote a lot of formation of acrylamide, but at the same time not affecting the sensorial characteristic. However, due to the acrylamide formation is related to the process, to the roasting process, it's very difficult to reduce the formation of the contaminant without affecting the organoleptic properties. But because of that, the food bureau in the acrylamide toolbox affirm that only very limited process options are available to reduce the acrylamide level without affecting the quality and the consumer acceptance of the product. It's really very difficult. And it's important to know what is the levels of acrylamide in the coffee beverages in order to know the really exposure to this contaminant in our diet, because we don't consume ground coffee, we don't consume the coffee bean, we consume the beverages. So for this, to this end, EFSA published the internal report on the harmonization of dilution factors, and according to this document, we can prepare an average strength coffee by mixing around 50 grams of coffee in 1 liter of water, and depending on the coffee that we use for this preparation, the levels of the contaminant can range between 0.9 to 1.8 microgram per kilo per cup if we consider a cup of around 100 milliliter. And comparing espresso and coffee beverages, the levels of the contaminant can range between 2.9 to 3.3 microgram per cup. And as you can see in the slide, the levels of the acrylamide in the beverage is much lower than those found in the roasted coffee, in the ground coffee, because we don't drink ground coffee. Another important aspect is what happens during the digestion process when the beverage is consumed and the contaminant is metabolized. Due to the high solubility, we might think that other acrylamide in foods could be available. However, this is a very reactive molecule due to the double bond in a vinyl group, and acrylamide is easy to react with other components in the food matrix, mainly through the Michael-type addition reaction. And in order to know what happened during the consumption of coffee, we conducted one study in a research group, and we studied different samples on instant coffee and coffee substitutes. All the samples were acquired in different supermarkets, and all of them were suggested to an in vitro gastrointestinal digestion, following the INFOGEST standardized protocol. The study included the study of the sample in isolation, only coffee, and the combination with milk, in order to evaluate the possible interaction between acrylamide with the different components of the food matrix and how this interaction can affect the acrylamide bioaccessibility. The acrylamide was determined in the initial samples and in the soluble and non-soluble fraction obtained after the in vitro gastrointestinal digestion, and these were the results. In the figure on the left, we can see the levels of the acrylamide in the initial samples, represented with the blue bar, and in the soluble and non-soluble fraction after the digestion process, represented with the green and black bar. With these results, we calculated the bioaccessibility, which ranged between 73 to 90% for soluble coffee and between 78 to 99% for instant coffee. One sample per group was digested together with milk, and the results are represented in the blue bar. As mentioned before, acrylamide is a very reactive molecule, and it can interact with different components in the food matrix, and mainly with a sulfhydric group from amino acid and also with melanoidins. The interaction between acrylamide and melanoidins has been previously reported, and maybe the formation of this complex could explain why the bioaccessibility of acrylamide was decreased in the case of soluble coffee. This fact was not observed in coffee substitutes made from cereals, where the acrylamide was almost totally soluble, reaching values of bioaccessibility close to 100%. The presence of milk didn't affect the bioaccessibility in the case of soluble coffee, but increased it in the case of coffee substitute made from chicory. One of the hypotheses of this result is that inulin present in chicory could react with amino acids that can be released during the digestion process, avoiding then the interaction with acrylamide, and in this way the free acrylamide was not blocked. And another components present in the coffee matrix, for example, antioxidant and fiber, cannot be discarded, and they have to be evaluated in the future, because maybe they can also explain this result. From this result, it can be concluded that it's important to explore the interaction between acrylamide and food matrix component, as they influence its availability during the digestive process and consequently the final risk of exposure to the contaminant. Further studies will be necessary to evaluate the acrylamide bioaccessibility when coffee is consumed in combination with other foods. Thank you very much for your attention.